Chapter 5, Section 4, Midsegment Theorem. The midsegment of a triangle is a segment that connects two midpoints of a triangle. When I say midpoints of a triangle, remember that a triangle is made up of three segments. So the triangle actually has three midpoints on each segment. A midsegment is a segment that connects two of those midpoints. So just like there are three sides of a triangle, there are going to be three midpoints of a triangle and three midsegments of a triangle. This example asks us to show that midsegment PQ is parallel to segment DE and half as long. To show that two segments are parallel, we need to find the slope of each line. So if you look at segment PQ, notice that the slope of that would be, you would go up one and to the right one. So the segment's slope would just be 1. If you notice to go from point E to point D, if you look at that segment, again, the slope is 1. You could think of it as 2 over 2, but 2 over 2 would simplify to 1 as well. So because both of those segments have a slope of 1, we can say that PQ is parallel to DE. This also asks me to show that PQ is half as long as DE. To show that this PQ is half as long, we need to find the distance from point P to point Q and from point D to point E. To do that, I'm going to use the points for Q and P, and I'm going to use the distance formula to say that PQ is the square root of 2 minus 1 squared plus 3 minus 2 squared. Well, 2 minus 1 is 1, and 3 minus 2 is 1. So the distance for segment PQ is the square root of 2. The distance for segment DE we can find by saying the square root of 5 minus 3 squared plus 2 minus 0 squared. Well, 5 minus 3 is 2 squared plus 2 minus 0 is 2 squared. 2 squared is 4, so the square root of 4 plus 4 is the square root of 8. There is a perfect square 4 that will go into the square root of 8, so we can simplify that to be 2 square roots of 2. If you notice, we've proven that PQ is only a square root of 2 long, while DE is 2 square roots of 2 long. So that does say that PQ is half as long as DE. The midsegment theorem says the midsegment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So a midsegment of a triangle is going to be parallel to the side that is opposite of it, and it is also going to be half the length. If you look, it says JK and KL are midsegments of triangle ABC. They ask us to find JK and to find AB. Notice JK is the midsegment that is parallel and across from side AC. Side AC, they tell us, is 10. So we know the midsegment that is parallel to that side has to be 5 for JK. And we're going to go the other way to find the length of AB. Notice we're not given the length of the triangle side there, but we are given the midsegment LK is 6. If the midsegment LK is 6, then that means that the side that is opposite or parallel to it needs to be twice as much, which means that it is 12. The next example gives us the diagram, and it says, what are the coordinates of Q and of R? Notice Q and R is a midsegment of the triangle in M in P. To find Q and R, we have to use the midsegment theorem, which says that when we add the x values and then divide by 2 of the endpoints, and then add the y values and divide by 2 of the endpoints, we would be given the coordinates of the midpoint. We've talked about the midpoint formula quite a while ago, so if you need to go back and look it up, then feel free to do so. When we use the midpoint formula, though, we find that point Q would be at A divided by 2, B divided by 2, and point R would be at A plus C divided by 2 and B over 2. The next question asks, why is QR parallel to MP? If you notice, QR would have a slope of 0 because it's a horizontal line, and MP would also have a slope of 0 because it's a horizontal line. Remember, two lines that have the same slope are parallel. So QR is parallel to MP because both have a slope of 0. The last question, C, says what is MP and what is QR? If you notice, MP, we are not given numbers as coordinates, we're given variables. But the length of MP, we go from the x value 0 to the x value C. We don't know what C is, but we can say that MP would have a length of C. And if MP is C, then QR would have to be half of that. So QR would be C divided by 2. The next example says, in triangle XYZ, which segment is parallel to segment XZ? Notice XY. Notice XY is the side of a triangle. The midsegment that is parallel to XY would be TU. Number 2 says, if ST is parallel to YZ, what is YZ? ST is a midsegment with a length of 4. YZ is the side that is opposite of it. So we know that YZ would have to be double the length of the midsegment ST, which means that YZ is going to measure 8. The next example says the midpoints of the sides of a triangle are S at 1, 5, T at 3, 3, and V at 4, 6. What are the coordinates of the vertices of the triangle? The first thing that we need to do is go ahead and plot the points, and I'm going to go ahead and connect them. Each line represented is connecting the midpoints of the sides of a triangle, which means each line would be the midsegment of the triangle that we're trying to find the coordinates of. Remember, there were two things that we said were true about the midsegments of the triangle. The first is that they are parallel. Remember, parallel, when we're looking at a coordinate plane, parallel means that they are going to have the same slope. The other thing is that they're going to be double the length of the midsegments. The sides are going to be. That's not really going to help me very much. It will help me check my work later, but the piece that's going to really help me is the parallel part, or the part that says that which means that they're going to have the same slope as the midsegment. So if we look at these lines that we've created, we can find the slope of each one of them. The slope of this line would have a slope of 3. This line would have a slope of 1/3, and this line would have a slope of -1. When we know the slope of the midsegments, I can use the points, the midpoints that they've given me, and count the slope that is opposite, or count the same slope as the midsegment that is opposite the point. So for this point, I'm going to count the slope of 3 and I'm going to draw a line. For this one, I'm going to count a slope of -1 and draw a line. And for the last one, I'm going to count a slope of 1/3 and draw a line. Notice then I have the triangle formed, and I can find the coordinates and say that the vertices are going to be at 0, 2, at 2, 8, and at 6, 4. Be careful, you might need a ruler for this if you're not very good at drawing, or you're not very accurate with drawing your lines. So make sure that when you're given a problem like this, you do have a coordinate plane to work with, like on graph paper, and that you are using a ruler and being as exact as you can be. The next example says RS, ST, and RT are midsegments of triangle XYZ. Find the perimeter of triangle XYZ. Notice I've been given the midsegment lengths for this triangle, but I have no lengths that are of the sides of the triangle. To find the perimeter of a triangle, I need to find the side lengths first. Remember that the side lengths are double the length of the mid-segments that are parallel, which means xy would have a length of 14, xz would have a length of 10, and yz would have a length of 12. To find the perimeter, I need to add up the side lengths. So I'm going to do 14 plus 12 plus 10, which gives me a perimeter of 36. Today's assignment is on page 290, numbers 12 through 19, 21 through 25, number 28, 33, and 36.